Hi, everybody. Welcome back to another lesson here. We have our geometry lesson, chapter 6, lesson 6. And in this specific one, we have a couple vocab words right here. We're going to talk about inequalities in two triangles, but our vocab words are indirect proof and inequality, which we've had those before. So I'm just going to say skip, and we're going to move on. All right, a couple theorems here. We're going to start off with this first one here. It's called the hinge theorem. Let me read this. Let me zoom out so you can actually see it on the screen here. It says, if two sides of one triangle are congruent to two sides of another triangle, stop. Notice over here at the diagram, we have Vx and RT are congruent, and we also have that VW and RS are congruent. Okay, so notice we have to have two sides that are congruent to two sides in another triangle. That is the key here. You have to have two sides of one triangle are congruent to two sides of another triangle. And then we're looking at what's called the included angle, which is the angle between, okay? It says, and the included angle of the first is larger than the included angle of the second. Then the third side of the first is longer than the third side of the second. So how does this work? What does it mean? If we have two sides that are congruent and we look at the angle between those two, the one with the larger angle, a side opposite that larger angle is going to be a longer or larger side. So since 88 is larger than 35, WX is going to be a larger or longer side than ST. So as you, hinge theorem, a hinge like on a door, as you open the door, the dimensions of the door don't change. The dimensions of the door post doesn't change. But as the angle gets bigger because you're opening a door, the distance between the door and the door frame increases. Okay? Then we have the converse. All right, the converse here says if two sides of one triangle are congruent to two sides of another. So again, we're starting with the sides. This now says, hey, if we have the two sides that are congruent, look at that third side. The larger side is going to go with the larger of the two angles. So since 12 is larger than 9, angle C is larger than angle F. So that is your hinge theorem and the converse of the hinge theorem. So let's get this into use. All right, next page. In exercises 1 through 9, complete the statement with some of these inequality symbols, less than, greater than, or equal to. And it says explain your reasoning. I'll just say the reasoning, but let's just write these down. So notice that we have two sides that are congruent. So AB is congruent to DC and AC is congruent to DF. So we have that first part. Now we look at the two angles. I notice here that 35 is smaller. Since 35 is smaller, that means BC is the smaller side and 45 being larger is the larger side. So EF is what's going to be getting eaten in our inequality because it's larger, or you can think BC being smaller is a less than symbol. So that is our hinge theorem. So if it said explain, this would be the hinge theorem. Okay. Number 2, again, we have the two congruent sides on both, and then we're given the angle. So 95 is bigger, so BC is going to be larger than EF. And why our hinge theorem? And let's look at number 3. We have the congruent sides here. And then we look at the inside, we have 90 degrees, but perpendicular means 90 degrees. Since they're the same measurement, these are going to be the same side lengths as well. And again, that's our hinge theorem. Okay. This also, if you want to look at it this way, their corresponding parts of congruent triangles are congruent because if you don't want to think about the hinge theorem, we can think about this as being side, angle, side, triangle congruence, and then you have corresponding parts. Okay, let's look at the next one. Now we are being asked about the angle measures. So I have some sides here that are congruent. All right. Now, if I look, I'm going to look at the angles. So they're looking at angle A and D. If I look at angle A, which is here, this blue one, and angle D, which is here, notice that A is between the 1 and 2. This is between the 1 and 2. But notice what's across from it. It is the same measurement. Okay, so one, this right here, because they are congruent, this would be a side, side, side angle congruent. So these would be corresponding parts of congruent triangles are congruent. But if you think about the hinge theorem, its converse would say if one's bigger than the other, then we have their inequality symbol. If they're the same, again, we're going to have equal to symbols here. All right, let's look at number 5. We have the congruent sides, but notice we have 14 goes with A and 16 goes with D, and 16 is greater than 14, so angle D is greater than angle A, so you put a less than symbol there. Again, this would be the converse of the hinge theorem. And then number 6, again, we have our two congruent sides, so look at 9 is larger than the 2. So angle A is going to be larger than angle D. Again, that's the converse of the hinge theorem. I know, really easy stuff. Probably shouldn't have to go through all these, but I will just because it's pretty quick and easy. All right, let's look at number 7, 8, and 9. All right, a little bit more stuff going on here. We have some extra stuff. Whenever you see a side that's shared, that is your reflexive property. So I'm going to put a little congruence mark in here just because in triangles ABD and ADC, they both have AD in common. So we have two congruent sides, and then notice our angle measurements here. We have angle 45, which is here, and that corresponds with BA. And then we have angle 35, which corresponds with AC. And notice that when we look here, 45 is going to be larger than 35. So that means BA or AB is larger than AC. Again, we're looking at side lengths, so this will just be the hinge theorem. Now, number 8, we have the two congruent sides, and we have two congruent angles here with the green, which means if they're the same angle, the sides opposite are going to be the same or equals. And then number 9, we have a shared side here. So we have our two congruent sides. We have the single marks, we have the double mark, and then ooh, look at the side lengths. We're looking at measures of angle 1 and 2. So measure of angle 1 corresponds with 19 and 2 corresponds with 17. Now, due to the converse of the hinge theorem, remember the converse is what lets us say which angle is larger than the other. What we're going to have here is since 19 is larger, that means angle 1 is larger than angle 2. All right, let's move on. All right, in 10 and 11, we want a proof. It's going to be a pretty quick, not super, I'm not going to make a super proper proof here, but let's just go ahead and do number 10. We have some givens here. We have given that xy is congruent to yz, which I see in the diagram, and I also see that wx is greater than wz. So if we're going to do like a proof here, I guess I could zoom out, or maybe I'll just move this up a little bit so I get some more room on this. First thing I'm going to probably write is that we have our givens here. So we have, oh, what is that? We have xy is congruent to, what did they put? yz. So here's yz. And we also have that wx, that side is greater than wz. If I said angle earlier, I'm sorry, I don't remember what I said now. So these are given. So Wx is larger than Wz. I'm just going to write down that this is smaller. All right, small, and this one's larger. Just so I have a little note in my diagram here. What do we also know? We have YW is congruent to YW because of the reflexive property. And now what we have is, since we have two congruent sides, right? So hold on, I think I just accidentally erased that. Yes, I did, sorry. See, because we have two congruent sides here, that's what I want. And we have this third side, we'll talk about one's being smaller, one's being larger. If I look at what's opposite here, angle y, so that'd be xyw, or WXY, and the one here would be WYZ, what I can say is the measure of WYX. So the measure of angle WYX, and that's going to be my green angle here. Okay, that is going to be smaller than my little yellow angle over here, which is going to be the measurement of angle WYZ, and that's because of the converse of the hinge theorem. All right, number 11, AD is congruent to BC, which we have in the picture. Measure of angle DAC is larger than ACB. So I'm going to quickly make that little note here that DAC, this one is larger, and then ACB down here, this one is smaller. And so we have our givens. All right, so we have our givens for our proof, but we also need to show that AC, I'm going to not write as much here, is congruent to AC. Helps if I can actually write that correctly, due to the reflexive property. And then after that, you'll notice since we have two congruent sides, that third side that is opposite. So if I go here, opposite A is DC. That is going to have to be larger than what is opposite our small angle, which is AB. So DC is larger than AB. That would be our last statement in our proof, and because of the hinge theorem. The thing here is you have to realize that we use our reflexive property. Okay, we are going to skip number 12. All right, let's go ahead and skip number 12 for now, and let's go to number 13. I like this one. I'm going to read it and we're going to draw a picture and figure out what's going on. Starting from a point 10 miles north of Crow Valley, a crow flies northeast for 5 miles. Another crow, starting from a point 10 miles south of Crow Valley, flies due west for 5 miles. Which crow is farther from Crow Valley? Okay, let's stop here for a second. I'm going to draw a little picture here. I'm going to have a point here. This is Crow Valley. And in blue, I'm going to read this and I'm going to draw it in blue. Starting from a point 10 miles north of Crow Valley, so that means 10 miles north means up. So I'm going to go up 10. A crow flies northeast. So remember, compass, north, east, south, west, northeast is going to be sort of like up and to the right. So instead of straight up, I'm going to go this way, and it's going to end here, and this is 5 miles. So that is crow number 1. Okay, this would be crow number 1. Now, crow number 2, says another crow starting from a point 10 miles south of Crow Valley flies due west 5 miles. What does that mean? 10 miles south means straight down 10. And then due west means straight to the right. This is going to be 5. I know it's not the same measurement. Sorry, I'm going to maybe erase a little bit of this, make it look sort of the same. Here's where they're going to end up. Now, since it says due west, that's actually a 90-degree angle here. Now, what we're looking for is it asks which crow, if I connected it from the beginning to where they ended, which one is further? Helps if I can make a little more of a straight line here. So which one's farther from Crow Valley? Now, let's look at this top one really quick. Instead of going northeast, what if I went north? What if I went due east? Due east on this top one would have been right here, where this red is. That would have been 90 degrees. So notice what happened is this crow went more than 90 degrees, where crow number 2 went 90 degrees. Also realize that we have two congruent segments. We have the 10 and we have the 5. So because of that, with the more than 90 degrees, remember, the larger the angle, the larger the distance, which means this is a longer distance because of our hinge theorem. Okay. So because of the hinge theorem, we know that crow number one flew further. All right, there are your notes. If you have any questions, feel free to reach out. If not, we will see you here at the next video or in class. Have a great day.